Hello everyone, alternating current for transformers. In this video, I will be discussing about transformers. Transformers are used for efficient power distribution. They help to step up and step down the voltage and thus reduce the energy losses during transmission. They are based on the principle of mutual inductance. Now you can see the construction of a transformer. A transformer consists of two coils, namely the primary and the secondary. They are wound on a transformer core. Primary usually is the input side of the transformer, while the output side of the transformer is the secondary. The same magnetic flux links both the coils. Now the voltage in the primary is stepped up or stepped down by changing the number of turns of the secondary with respect to primary. There are two types of arrangement of these coils around the transformer core. These are as shown in this figure. That is, in one, both the secondary and primary are wound concentrically as shown, and in the second case they are kept apart and wound on each side of a rectangular transformer core. Now we can see the working of a transformer. That is, when an alternating voltage is applied to the primary, the resulting current produces an alternating magnetic flux, which links the secondary and induces an EMF in it. This is due to mutual induction, and hence the value of this EMF depends on the number of turns in the secondary. Now the induced EMF epsilon s is given by negative ns into d phi by dt, where phi is the magnetic flux and the negative sign is due to Lenz's law. Similarly, an alternating flux phi also produces a back EMF in the primary, and it is given by epsilon p is equal to negative np into d phi by dt. We can take epsilon p is equal to Vp, that is the input voltage in the primary. This is taken on the assumptions made that primary resistance and current are small. Similarly, the voltage induced on the secondary, epsilon s, can be taken as Vs. That is, the same flux links the primary and secondary as very little flux escapes from the core, and also the secondary current is small. These assumptions are taken into account to approximate epsilon s is equal to Vs. Now Vs by Vp can be written as Ns by Np. As the ratio of voltage just in the secondary and primary is equal to the ratio of number of turns of the secondary and the primary. Now if transformer is 100% efficient, then according to conservation of energy, input power will be equal to output power. That is, IP Vp is equal to Is Vs. Hence we can write the equations as IP by Is is equal to Vs by Vp is equal to Ns by Np. Now using this relation, we can explain the two types of transformers. That is the step up and step down transformer. If the secondary coil has a greater number of turns than the primary, that is Ns greater than Np, the voltage is stepped up. That is Vs greater than Vp. This type of arrangement is called a step-up transformer. In this case, the current in secondary is less than in the primary. This is due to the law of conservation of energy. That is, if voltage increases, the current has to decrease for the power to remain constant. Now, in the case of a step-down transformer, the secondary coil has a lesser number of turns than the primary. That is, Ns is lesser than Np, and the voltage is stepped up. This type of arrangement is called a step-down transformer. In this case, the current in secondary is greater than in primary. That is, Is will be greater than Ip. In practical cases, the transformers does not possess 100% efficiency. Some of the energy are lost, and in practical transformers, the efficiency is usually 95%. And the reason for these energy losses are, first one, flux leakage. There is always some flux leakage. That is, not all of the flux due to primary passes through the secondary due to poor design of the core or the air gaps in the core. It can be reduced by winding the primary and secondary coils one over the other. We have already seen such an arrangement in the construction section. Now, resistance of windings. The wire used for windings has some resistance, and so energy is lost due to heat produced in the wire. That is I square into R. In high current, low voltage windings, these are minimized by using thick wire. Now, eddy currents. The alternating magnetic flux induces eddy currents in the iron core and causes heating. The effect is reduced by having a laminated core. And finally, hysteresis loss. That is, the magnetization of the core is repeatedly reversed by the alternating magnetic field. The resulting expenditure of energy in the core appears as heat and is kept to a minimum by using a magnetic material which has a low hysteresis loss. So this is the end of this video. In this video, I have discussed about the construction, working, and energy losses of a transformer. If you have got any doubt, please comment in the section below. Thank you.